Hello students, in this video I am going to teach you how to solve the problems based on proportion. Welcome to our channel E-Kalike. So let's solve the problem. The first one is find the fourth proportion to 1.5, 4.5 and 3.5. So we have one more problem, 3a, 6a square and 2ab square. So let us solve the first one, that is 1.5, 4.5 and 3.5. We need to find the fourth proportion. I am assuming let that be x. Let the fourth proportion be x. If that is x, let's write the remaining in the proportion. If I write that in the proportion, I'll be getting 1.5 is to 4.5 as 3.5 is to x. So we already know the product of the extremes is equal to product of the means. So 15 into x must be equal to 4.5 into 3.5. So 1.5 into x is 1.5x, which will be equal to 4.5 into 3.5. So this is 1.5x. If I multiply this, I will be landing up with, on multiplying this, I'll be getting 15.75. Now I need to find x. Therefore, x is equal to 15.75 divided by 1.5. So on dividing this, I will be resulting with the answer 10.5. Therefore, the fourth proportion is 10.5. Let's solve the next one in the same manner. So I have the number 3a, 4a square and 2ab square. Again, let the fourth proportion be x. If I write this in a proportion form, I'll get 3a is to 6a square equals 2ab square is to x. Again, the product of the extremes is equal to the product of the means. So 3a into x is 3ax. That should be equal to 2a square into 6a square into 2ab square. 6 2s are it's 12. A square into a is a cube. Again I get b square. I need to find the x value. So I retain x and remaining terms I'm going to shift towards the other end. So I result with this 3a. Now 3 1s are 3 4s are x. And 1a cancels with the 1a over there. Now I have left out with x is equal to 4, a square, b square. Therefore, the fourth term is 4a square, b square. Let's go for the second problem. Find the third proportion to a minus b and a square minus b square. So seeing this question, we can come to a conclusion that this problem is a third proportion problem. It's a continued proportion problem. So let the third term or third proportion be x. Since it is a continued proportion, we get only 3 terms. The b term will be repeated. Therefore, the third proportion be x. So we have learned this in the last video. So the continued proportion will be a by b, which will be equal to b by c. Now I have taken c term as x. If I write this in a continuous proportion, I get a minus b divided by a square minus b square will be equal to a square minus b square divided by x. Let's cross multiply the terms. I get x into a minus b will be equal to a square minus b square multiplied by a square minus b square. If I expand this, it's in the form of a plus b into a minus b into a square minus b square. On this hand, I have x into a minus b. So a minus b and a minus b get cancelled. Now the x value will be a plus b into a square minus b square. The third proportion is a plus b into a square minus b square. Let's go for the third problem. What is the least number which should be added to each of the numbers 6, 15, 20, 43 to make them proportion? Now these numbers are not in proportion. To make them proportion, I need to add some number, the least number. So let that least number be x. I'm going to take the least number as the x now. If I add to this number, what happens? These numbers will be in proportion. So I'm assuming the least number as x. Now if I add the 6 to each number, then these numbers will be in proportion. Let me write it. 6 plus x is to 15 plus x will be equal to 20 plus x is to 43 is to x. The product of the extremes should be equal to product of the means. So 6 plus x into 43 plus x will be equal to 15 plus x into 20 plus x. Let's multiply the binomials. So 6 into 43, I get 258 plus 43 into x is 43x plus 6 into x is 6x plus x into x is x, which is equal to 50 into 20 is 300 plus 20 into x is 20x plus 15 into x is 15x plus x into x is x square. You can see x square and x square being cancelled. So you have on the both sides, so I have cancelled. Now let me write 258 plus, what is 43 plus 6? It's 49x, which is equal to 300 plus 35x. I'll bring this 35x towards this side and 258 towards this side. Let's see what happens. 49x minus 35x will be equal to 300 minus 258. So 49 minus 35 is 14x, which is equal to 42 here. Now the x is 42 by 14. So 14 threes is 42. Therefore, the least number to be added is. The next problem is, what least number must be multiplied from each of the numbers 7, 17 and 47 so that the remainders are in continued proportion? So let's assume the number be x. Since we are taking the least number, that be x. If that is x, what will be the remainders now? That will be 7 minus x, 17 minus x, 47 minus x. In the question, they have specified the remainders will be in a continued proportion. If they are in continued proportion, I can write a by b is equal to b by c. Let's cross multiply the terms. Let's see what happens. On cross multiplying, I get 7 minus x into 47 minus x, that is equal to 17 minus x the whole square. Let's expand this. On expanding this, I get 329 minus 47x minus 7x plus x, 289 minus 34x plus x square. You can see here, I'm shifting this 289 this side, you get 329 minus 289. You can see here, minus 47x minus 7x, it's nothing but 54x. I bring that towards this side. And you can see x square and x square being cancelled out. So I get 54x minus 54x was there. I have changed the position. It becomes plus 54x minus 34x. Now you get 20x is equal to 40. You get 40 from here and you get 20x from here. Therefore, x is nothing but 40 by 20, that's 2. So 2 is the least number that is needed to be added. The next problem is, if three quantities are in continued proportion, show that the ratio of the first to the third is a duplicate ratio of the first to the second. If three quantities be x, y and z, then x is to y is equal to y is to z. And we need to show that x is to z is equal to x square is to y square. So in the question they have mentioned the three quantities. So even they have mentioned the three quantities also, x, y and z. And they have told they are in continued proportion. So we have learnt about the continued proportion. So that is x by y is equal to y by z. So we can write this as x is to y is equal to y is to z. Right? Now let's write in a cross multiplied form. So if I write this in a cross multiplied form, I get x into z is equal to y square. X into z is equal to y square. So let's multiply x on both sides. I want to multiply x on both sides for this. So I get x into xz is equal to y square into x. So this becomes x square into z is equal to x into y square. So if I write this in the ratio form, what I'll get, x square by z is equal to x by y square. Now let's cross multiply this. On cross multiplying, I get x square into y square is equal to x into z. And if I write it in a form, I get x is to z is equal to x square is to y square. This is what we require. Let's go for the next problem. If y is the mean proportion between x and z, prove that x square minus y square plus z square divided by x raised to the power minus 2 minus y raised to the power minus 2 plus z raised to the power minus 2 is equal to y raised to the power 4. So in the question already discussed that y is a mean proportion between x and z. Therefore, y square is nothing but x into z. Now let's take the LHS and let's prove the RHS. So let's write the LHS, x square minus y square plus z square divided by x raised to the power minus 2 minus y raised to the power minus 2 plus z square. Z raised to the power minus 2. The first thing, let's convert this negative powers into the positive. That is, bringing them to the denominator. Now it becomes x square minus y square plus z square divided by 1 by x square minus 1 by y square plus 1 by z square. See, wherever y square is there, in that place, let's substitute its value, that is xz. So on substituting this value, my LHS becomes minus x square minus xz plus z square divided by 1 over x square minus 1 by x into z plus 1 over z square. Let's take LCM in the denominator, and the denominator you have x square, xz and z square. On taking LCM, you get x square and z square as the LCM. So the first term, it will be z square minus xz plus x square. Since the LCM is x square, z square. You can see this term get cancelled with this term. Whole term get cancelled. What remains? Only this term remains in the denominator of the denominator. It goes to the numerator and you land up with x square, z square. So this can be written as xz whole square. So what is xz whole square? Xz is nothing but y square. To the whole square, I land up with y raised to the power 4. This is what is the RHS I need to